For Unit 5, Lesson 2, we will be discussing the various ways you can calculate the enthalpies of a reaction. During our last lesson, we discussed enthalpy, or delta H. We can now associate an enthalpy with a reaction. We call these thermochemical equations. They're balanced chemical equations that show the associated enthalpy change. For example, the delta H for this reaction is 28.1, meaning it's an endothermic reaction. Let's review using our delta H's for these reactions to do some stoichiometry conversions. For question 1, we are asked to find which reaction is endothermic. Remember, endothermic should have a positive delta H. So reaction 1, where enthalpy is positive, would be an endothermic reaction. For question 2, we are converting between grams and energy. We want to start with our 3.5 grams, use our molar mass to convert to moles, and then finally use the ratio of 2 HCl to 185 kilojoules to convert to energy. There are a couple different ways we can calculate the enthalpy of a reaction. One way is with Hess's law. We sum a series of steps to equal an overall reaction. For example, if we have this first reaction listed here, we would add together a combination of the three equations down below to calculate our overall enthalpy of a reaction. There are two rules to keep in mind when we're adding together the enthalpies of a reaction. If we have to multiply our equation by some number, we must also multiply the delta H. Rule number 2 is that if we flip our reaction, making our reactants the products and the products the reactants, we must also flip the sign of the delta H. Let's try example number 1. Given equation 1 and 2, we want to determine the delta H of the following third reaction. So our goal is to manipulate the first two simpler reactions to get our overall third reaction. The first thing I check is to make sure the reactions 1 and 2 are written correctly. I don't need to flip them or reverse them. P4 should be on the left, and it is, and Cl2 should also be on the left, which it is. So both reactions do not need to be flipped. Second, I make sure reactions 1 and 2 add together to give me reaction 3. PCl3 appears on both the left and the right of my equal sign, so it would cancel. And then 3 halves and 1 full chlorine would make 5 halves. So they do add together to give me my third reaction. My last step would be to add together the delta H's for the individual reactions. In this example, neither delta H needed to be manipulated, so I'm simply adding together the two values. The last way we can calculate the enthalpy of a reaction is to individually sum up the enthalpy of formation of the products and subtract them from the sum of the enthalpy of formation of the reactants. These values can be found in Appendix C of your textbook. For example number 4, we're going to be calculating the heat of reaction for the formation of glucose. So first we're going to take our two products, use their number given to you in the table, multiplied by their coefficient, add them together. Then we're going to subtract them from the reactants, their values given in the table, times their coefficients. Well, there you have it, another chemistry lesson with Miss Gates. Make sure you hit the like button and tweet me at Miss Gates Science.